Hi, at the end of part one of this video, well, we had just completed the milling of our first surface on our small rectangular block that's going to be cut up into sections to make several small tab blocks. On verification, I checked with my very nice little Starrett precision square. This is actually a small die maker square that you can use to give a small angle on the ruler of the square for measuring die clearances, but it is an accurate 90-degree square as well. And using my square, I noticed that my blocks are a little out. Not a lot, but a little. So I investigated a little further, and it took me to a common problem and something that I fully expected to find, and that is that, seeing as I'm quite a big guy, I tend to over tighten my vise, especially when it's on a swivel base, and that actually tilts the fixed jaw out of alignment. Now, what can be done? Well, obviously tightening a little less vigorously could really help, because as I said, I do tend to over tighten. And also getting rid of the swivel base. Now, swivel bases are nice to have, but we don't need to use them that often. Really, we can dispense with them for 95% of the jobs that we work on, really, or if not more. But using the swivel base lifts the vise off the table and really supports the vise only on its center. The end of the vise oftentimes overhangs, it's cantilevered over the swivel base, as is the back end of the vise here. And supported just in the center, while the front and the back can actually flex. There's nothing underneath to hold it. So the first thing that I'm going to do to give me a little more rigidity on my vise and increase the squareness of my part, reduce the deflection of the fixed jaw, well, it's going to be to remove that swivel base and fix my vise directly onto the table. That will give the base of the vise full contact with the table, and obviously the table is quite rigid, and that will increase the rigidity of my vise. So let's do that. So as you can see, I've installed some finger clamps. And why did I do that? Well, the objective of getting this vise down onto the table was to increase its rigidity. And if I use the holes that are in the base of the vise, well, I'm going to line up with one of the grooves here, and I end up with a vise that overhangs, or overhangs quite a bit on the other end. But it doesn't give me a good contact in this crucial area that I want. So if I'm going to have contact right to the end of the vise, as is the case right here, well, I'm going to have to use finger clamps. And that is fine, there's no problem with doing this. However, one must be careful when using finger clamps that the clamps don't lean away from the part. The heel end of the clamp has to be slightly higher than the pressure applying end of the clamp. We want the end of the clamp to push directly towards the table. We don't want an angular clamp that the heel has lower pushing the part away. So it's important to get the height right. And you'll see that I'm using a washer here as a shim, just to ensure that I know where the point of contact is. This is a good way of doing that. Now I have one on each end here. It's also good to have an idea of how the clamp applies force onto the part. If we look here, I have about from the center of the stud to the end here, about 1/4 and 3/4 of the length of the finger clamp in the back here. If I apply 100 kilograms of force with this tightening nut, well, it's going to be distributed onto the parts, the two supports, in an equal fashion if the stud is in the center. So if it's in the center, I get 50-50. 50 kilograms, 50 kilograms, 100 in the center, because really I can't create any force. I can just redistribute it. But if I have, as I have here, about a quarter of the distance up here relative to this distance here, which is about 3/4 of the length of the finger clamp, well, I distribute the force differently, and it's inversely proportional. So in this case, I have 3/4 of the force holding my vise down, and only 1/4 of the force holding the back support, which is fine. I don't care about holding the back support. It's the vise that I want to hold. So really, it's important to get the stud as close to the part that you want to hold as possible. And just to avoid any confusion, when I talk about the stud, well, I'm talking about this part here, and not the stud that's doing all the talking. And I want to align the vise now. Now, I don't have the vise keyed because usually this vise is on a swivel base. I could key it, but it's not important for me right now, but I do want to line it up, and that means that I'm going to have to pivot it. Pivot it around what? I'm going to pivot it around this point. So I'm going to snug this clamp down, not deathly tight, but snug, and this one is going to be a lot looser. It's still going to be snug very slightly, but a lot looser than the other one. And that means that when I pivot this around, well, I'm going to be pivoting around this center point, and that helps me with the alignment. So let's do that alignment. Well, that is just great. So now I'm going to snug up slowly to make sure that I don't move the vise while I'm tightening it down. There you go. The vise is tightened down solidly to the table. And now's the time to find out, have I taken care of my flexibility problem? So I'm going to perform a little flexibility check, and for that I'm going to head back to the end of the jaw on this vise, install a piece and a part, and tighten the vise down or over tighten it slightly to see if I'm going to get movement on my jaw and how much movement I get. And at the same time, as I'm traveling down, well, I'll be able to ensure that I haven't moved my part while I was snugging it or tightening it down. Okay, so the alignment's good. Let's install our part. Okay, I got about 2/1000 movement on there. And that would seem like a lot, but I really have over tightened my vise. But compared to what I was getting earlier on, well, this is phenomenal. So I have increased the rigidity of my vise, and we're ready to carry on with the squaring up of this block. So on to the next surface. There, we have our squareness problem under control. So let's move on to our next surface. Using a fine file and hand holding the part, we're going to remove any burrs that we may have produced with that last cut. But since we removed very little material with that final skim, the burrs are going to be very small, if there are any at all, because I had deburred the part previously. So let's just make sure that nothing's going to interfere with my vise jaw and throw me out a square. So let's just clean those up. Everything's nice. Now we're going to do the opposite surface of the one that we've just produced, ensuring or making sure that that same first reference surface comes to rest up against my fixed jaw on the vise, and again avoiding over tightening the vise. Now this first surface that we're going to cut is going to end up having a dimension. The second surface, I mean, because it's opposite the first, it's going to give us our first surface, our first pair of dimensions. And really, when you cut your surface that's going to give you your dimension, well, we're going to come up on it slowly, but it's important to remember that if you have different dimension, and in this case we have 3, that goes from the thickest to the thinnest, well, you're going to want to start by attacking the thickest dimension first. And why is that? It's just a question of saving your ass if you get yourself into a problem. Now, if you're cutting your first surface thickness by doing a pair of surfaces, it has to be parallel and it has to be at the proper dimension. Now, if you miss your mark and you end up cutting it a little bit under, well, amazingly, as long as you've started with the longest or the highest dimension, well, you can then shoot for the second highest. You haven't scrapped your part. And that is the proper order to do things. Really, in machining, many of your choices have to do with leaving doors open, giving you ways of getting yourself out of trouble. And this is one. Start by cutting the highest dimension and work your way to the smallest. And if you do have a problem, well, sometimes you can say, oh, well, this becomes my second highest dimension. So let's set up and take that cut. Now I'm going to take a first measurement. Now I know I'm not even close to my dimension, but I'm going to, with the micrometer, verify that end to end that I'm parallel, okay? I'm sure that I'm square this way. I verified the vise. I'm sitting on my parallel. All is well. But lengthwise, I'm not sure how things have worked out since I've reinstalled this vise. I haven't checked the bottom of the vise to see how parallel it is to the table. So I'm just going to measure end to end, one at each end, and verify that I am good and parallel before I carry on taking stuff off here. Okay, 924 thousandths of an inch on this end of the part, and 924.5 thousandths of an inch on the other end. I've got 5/10 thousandths of an inch out end per end, and that is, for this type of machine, very, very good. So I am more than happy with that. But it also indicates to me that I have about, pretty well exactly, 100 thousandths of an inch to take off. Now on this block, this highest dimension is 13/16. Now 13/16 is 0.8125 thousandths of an inch, or if you prefer, 812 and 5/10. I'm not worried about tenths here, okay? It's not that accurate. This isn't a grinder, it's a mill. So that means that I'm really shooting for 3 decimals. And if we're going to round up that 13/16 to 3 decimals, well, 5 up, 4 down, that means that we're shooting for 813 thousandths of an inch. This block is the one that's going to be sent out for grinding. The blocks produced from this one are going to be oversized by 10 thousandths. Now, oversizing isn't crucially accurate. 11 thousandths would be fine. So if I take 10 thousandths off, 100 thousandths off of this, that's going to bring me to 0.824, and that is my 10 or 11 thousandths over 0.813. So I'm not going to show all the cuts here because it's just repetitive, but we're going to skip ahead and come back to the final cut for this dimension. Then we're going to pull apart, head over to the bench, deburr it, and measure final, just to ensure that those 2 surfaces are truly parallel and to the proper dimension. So as you've seen, we've set the depth of cut here for our final cut at 10, 11 thousandths of an inch. So let's take the cut. Okay, so 823, 824, I'm in the zone, I'm about where I want to be. I have my 10 or 11 thou over dimension for grinding, so all is well here, and we can move on to our next pair of surfaces. Now this pair ends up at 5/8, 0.625, but I'm going to want to leave 10 thousandths on for the grinding. So in this case, I'm going to shoot for 835, 635. So 5/8, 625 once ground, but over dimension 10 thousandths, I'm going to end up at 0.635. Okay, now this pair of surfaces has or incorporates the surface that I prepared earlier on. So this time I'm going to hold it with my reference surface being the one that was up when this was on the side, or anyways, the pair that I just finished, one of the 2 up against the back surface, and the first reference, the one that I finished on the sander, well, it's going to be down on my parallel. I'm going to skim the first surface, leaving as much as possible on, then I'm going to turn the block over, making sure that my original reference, or the side that was against the fixed jaw for the first pass, ends up being the same one for my second one. I want to keep everything even or equal or the same. The less variation there is, the more precision we get. And obviously when I'm going to cut the second one, I'm going to bring it down to get my 0.635 or 635 thousandths of an inch. So here again, I'm not going to go through all the process. We're going to set up, cut the first surface. I'll show how I flip it over, and then we'll show the last cut on the second surface, and that pair of surfaces will be done. Okay, I have my part. I'm going to be setting up for my second pair of surfaces, the ones that are coming down to 5/8 or 0.625. In this part's case, 10 thou over, so somewhere around 0.635. Now, I'm going to put my first prepared reference, the one that I prepared on the sander, and getting it just flat. I'm going to put that surface on the parallel, and I'm going to put one of my two primary surfaces up against the fixed jaw. Which one is really not important at this point, but one thing's for sure, once I choose, I want to stick with it. So I'm going to put this surface up against the fixed jaw, and I'm going to identify it just with a black permanent marker. Black isn't important, but I want two different colors because I'm making two parts that are quite similar, but that are slightly different. This one is 10 thou oversized on all its dimensions, whereas the other part I'm making like this is going to be pretty well size for size. So the other one I'm going to use a blue permanent marker. And why black and blue? Well, because those are the two colors that I have. Okay, so that being said, we don't want to start flip-flopping our blocks around and changing. And this marked surface is going to be my new reference surface. Once I've milled the first end of my second pair of surfaces, I'll make a black mark on that one as well, because that's going to become my reference for that pair of surfaces. Okay, so that's my first of the surface for my second pair of surfaces. So I'm going to mark it with my black permanent marker. So I have my reference surface here, reference surface there. Now, everything else that's going to come off of this pair of surfaces is going to come off the other end. So I want reference down, reference back. I'm going to reinstall my part. Okay, so the part's installed, and now I'm going to take a large number or many successive cuts because I have, somewhere around 3/8 of an inch to come off of there. Okay, I've been cutting away at my last surface, and I'm shooting for 635 thou or 0.635. I know I'm close. I'm probably within 10-15 thou, something around there. So now would be the time to really take an accurate measurement and find out how much more do I have to take off to get to my dimension. And here's a trick that can really speed things up for you in the home shop, and that's to use one of these digital calipers, and where you're going to use the depth measurement portion of it so that we see only what we need to take off. So we'll zoom in on this tool and I'll show you how to do that. So here I have my caliper. I'm going to close it right up and I'm going to set it to 0. So it's 0 when it's closed. Now I want my part to be 635 thousandths of an inch. So I'm going to open this up, snug it down a bit to make it easier, and I'm going to open it up to 635 thousandths of an inch, and I'm going to zero it there. So this opening is what I want to end up with. Now all I have to do is measure the part, and I'll know the difference between 635, or my 0, and what I actually have. So let's see what we have here. I'm going to measure from the top of the part to the top of the parallel. Line things up, come on down. Here we have, pretty well 10, 10 thousandths or 11, maybe. Okay, we'll call that at 11 thousandths of an inch. So that means I have 11 thousandths of an inch to come off of there. It's just that simple. So let's take 11 thou off. Well, a lot of milling has taken place. And what do you end up with after all that? Well, in my case, I end up with two blocks that are almost the same. Okay? I have my almost size per size block that I'm going to finish into 4 or 5 different tools, okay, of the same nature, the same tool basically, but maybe 5 of them. And it's just going to be lightly polished after heat treatment, so I've left 1/1000th of an inch. It's my blue reference surfaces, and I've written right here that it's plus 1/1000th of an inch. So this block actually measures 0.626 and 0.814, 1/1000th over in each dimension. And then I have my other block that's quite similar, really almost the same, but it's my black reference surface block, and it's my oversized block. It's the one that's going to make the tools that are going to be sent out for heat treatment and grinding by someone else, and eventually end up in the what's in your box toolbox, I hope, if they're good enough. So anyhow, this would be taken from this bar, and this bar measures 10 thou over for grinding, so it measures 0.635 instead of 625, and 0.823, so 823 instead of 813. Okay, so 10 thou over. Now in both cases, and as I've said, this machine really makes you work for it, but with a lot of attention and to detail, I managed to get both on the mill without any other finishing within 1/1000th of an inch of what I've just mentioned these blocks actually are, well within 1/1000. So it does work. Now, what do I want to do now? Well, I still have my tertiary surfaces to define, and the ends of this block aren't accurate at all. I'm going to want to make them accurate, square them up. And to do that, I'm going to use a regular end mill, not the carbide one I have there, because it's really a face mill. It's not really made to cut on its side very much, but these fluted end mills are made to cut on their side, and I'm going to do some side milling. So I'm going to set my part up in the vise so that it just slightly overhangs the edge, and I'm going to mill the end just enough to square it up. Then I'm going to turn my block over, and I'm going to mill the second side. And that will give me two references. That I can then cut those two blocks off, re-mill the ends that are left on the main part of this that I haven't cut, and that'll give me two other blocks. And maybe I'll manage to get a fifth out. So then I'll have 4 or 5 blocks that have one good tertiary surface, and I'll set up for a production style final cut of those 5 half-inch blocks to get them, in this case, to my 10 thou over, and in this case to my 1 thou over. And now I think you can see why I'm using blue reference surface and black reference surfaces, because before long I'm going to end up with 8 or 10 little blocks, and I'm going to have to remember which are size per size and which are oversized. It's going to get a little confusing. So let's head back to the mill, set up our, in this case, high-speed steel end mill, and do some side milling. Well, that is a nice flat and square tertiary surface. And it's square because I sat my reference surface down onto a parallel, and I had aligned my vise very precisely at the very start of this project. And that's why I lined it up, because up until now, all the milling that I had done didn't require that the vise be aligned. They were two-dimensional milling operations. This tertiary surface is the first three-dimensional milling operation and requires a squared up vise. So, easy way of getting two ends. And once I cut these into sections, well, each section will have a good end. And that will make my life a lot simpler. So now I can do the same on the other block, and both blocks will have good tertiary ends. And that'll be enough for this part 2 of this project video on the tap block project. Next time we get together for part 3, well, we'll be cutting these blocks into smaller blocks and milling those cut ends to their final dimensions. And I should end up, as I said, hopefully with somewhere between 8 and 10 blocks that will become tap blocks. Then we're going to be looking at the plan, the drawing of this project in detail to figure out how we're going to attack the drilling of the holes, because there are 7 holes to be drilled in each of those small tap blocks. And that's going to be interesting to define a proper order or a sequence to get those holes in properly and accurately. So until then, have fun, be safe, and happy machining.
You